So today I want to talk about a tool that I thought would be appropriate for a combined Indy AWS and Indy Pi get together, namely a tool written in Python, extensible in Python, that helps you manage your cloud resources, especially in AWS. And that is this tool called Cloud Custodian. Yeah, let's do that. Bear with me as I stumble through Mac OS. The folks who know me know that's probably a very alien thing for me.
You using Mac OS.
Yeah, blackmail material. I'll post it in public where your friends will see it unless. So let's talk a little bit about what Cloud Custodian is and why it's around and what kind of thing it was intended to do. So go back a few years, and if you're at Capital One, you are building a bunch of infrastructure in the cloud. You're moving a bunch of stuff to the cloud. Cloud is this big deal. You're using AWS, and all of a sudden, you're starting to get tons and tons of resources everywhere. Lots of instances, lots of these S3 bucket things. And then there's this new thing, RDS. You can do the database without having an instance. How amazing, right? And you're finding all this stuff. You're creating all these things. You're like, this is all fine and good, but how do I keep track of all this stuff? And even worse, like if you've click ops your way through everything, if you don't know the term click ops, it's basically using the console to create everything via clicking instead of like writing it in some kind of declarative language that you can then track and version control and check against your infrastructure and all kinds of other good things. So if you're sitting there, you got all these people click opsing all kinds of stuff and creating all kinds of resources. A, how do you even know what you've got? And B, how do you know that the people who set this up actually set it up right? And, especially if you're a bank, you have compliance requirements, you have security. People tend to take a dim view of the notion that they log in and someone has taken all their money out of their account. I don't know why. It's a mystery to me. So you have to figure this all out. And you're like, at this time, this is like the mid 2000 teens or so. There's not really a whole lot of tools to do a lot of this stuff. Or if the tools exist, they're either super expensive or super hokey. So what do? You create your own tool. And that's what Capital One did. They created Cloud Custodian to solve this problem, figuring out what you've got, is it set up right? And in some cases, even being able to fix things that they find. This was a successful project. They open sourced it. It was super successful, super popular. And at some point, the Capital One folks realized they really had a gold mine on their hands. And so rather than, okay, we're going to, take time away from doing banking stuff to like do an open source project and become a tech company, they decided to spin it out to its own company called Stacklet. Stacklet is the company behind Cloud Custodian. They do a lot of services on top of it, but they have done a very good job of maintaining the Cloud Custodian open sourceness of it. So it's not necessarily an open core model. Everything is still open. They are very responsive to participation by their community. There's a whole lot of stuff that's gone in. Just very recently, a really major feature is in the process of getting merged in that everyone's excited about. And it was written entirely by an outsider, not someone at Stacklet, which is like excellent for, top tier from the point of view of an open source project run by a company. So kudos to Stacklet for doing all of those great things. And so over the years, they've just made it better and better, adding more information, adding more capabilities, and till we have today where it is being used by a lot of people, AWS people and so on, to manage their cloud resources and keep track of things and figure out what they've got and where it all is. All right. So there's a lot of complication in the cloud space, and anyone who's done anything serious in AWS knows that cloud can be quite fun. Cloud Custodian is refreshingly simple in that basically what it is a tool to run policies. Policies are descriptions of what you want to keep track of and what types of things you want done to the things you're keeping track of. So here, for example, we have a very minimal policy. And of course, everything is in YAML. Everyone who loves YAML, raise their hand. Y'all good? Got YAML fans? Anyone hate YAML? There we go. All right. So sorry, Cameron, we're giving you YAML. But you write them in YAML, you write the policies in YAML, and it's very, very simple. There's a policies key in the root level object has a policies key. And it has a bunch of, it's an array that contains individual policies that describe some resource and some set of things that you're going to, you want to find out, and also things that you're going to do, which we'll get to in a little bit. But this is probably the very simplest policy you could write. The name kind of describes it, all EC2 instances, and it is the resource, there's a resource description, aws.ec2. For the AWS folks are like, oh yeah, I think I know what that is. And the Python folks are like, maybe a little confused. So let me describe real quick. EC2 stands for Elastic Computing Cloud. In AWS, this is essentially the virtual machine system in AWS. So if you want to create a VM, this is how you do it. You might have more than one of these. You might have a whole bunch. You might have dozens, hundreds, thousands of these things that you've created. And if you want a list of all of them, this is a good way to do it. By referencing the resource of aws.ec2, which tells you this is AWS, the cloud provider is AWS, and it's the EC2 resource type, which is basically a virtual machine inside EC2. And with this policy, you're going to get all of your instances. So now, and this is the part where I do some very dangerous stuff when using someone else's laptop, and that would be a live demo. So what I'm going to do now is I'm going to run a policy, run that policy. If actually, I'll go ahead and show you. That's the policy, and it's basically what was in the presentation. And if we run it, which I will do right here, it sits there and thinks about it for a bit. And then it says, oh, look, I found 2 resources. And now this isn't terribly useful right here, but A, there's some data, which I'll show you in a minute. There's some data that's stored now in the file system. And B, you can run custodian report to get the information that you just gathered. And if you run that, you'll see, hey, look, there's this stuff. Here's your names. So in this case, we've got 2, Debian 1 and Debian ARM64 GP2. Instance types, launch times, all that good stuff. And this is controllable, so you can specify different fields if you want. Also, report will do things like export to CSV and do some other fun stuff. So that's the basic idea. You write a policy, you run custodian, it tells you things. And that's the basic idea. You can also look, and this is kind of an interesting part of this. You can run out. You can actually get a hold of the raw data coming back from AWS. So for folks who don't know on the AWS side, again, I'm trying to keep everybody on the same page here, the AWS folks and the Python folks. Most cloud services are run via an API that, like a traditional REST API that does JSON, returns JSON as its output. And so what you're looking at here is the actual JSON that came back from the AWS APIs that it's using to do all of the things that it does. And this will become important here in a minute. But you can see there's all kinds of fun JSON stuff in here. You get the idea. And all of these fields are available to custodian to use in interesting ways. So let's see. Yeah, hello. There we go. We'll go back here. So, all right. So that's the very, very basic, most like low level type of thing you can do in Cloud Custodian. Now, a lot of you are thinking that's not terribly useful because, okay, I know that I have 6,972 EC2 instances in my cloud provider. I didn't need you to write me a tool to tell me that. Give me something useful here. And so the next thing we're going to talk about is filters. Filters are the query language behind Cloud Custodian. This is how you take your 6,000, however many I said before, resources and pare it down to just the specific things you care about. Usually these are the problem children, the things that are not doing the right thing, that are, maybe not quite in compliance with whatever policy you need to be in compliance with, like, and I'm talking here like regulatory policy or something like that. Or maybe this is set up wrong, or it needs an upgrade, or it needs some other attention. It's giving you problems. In this case, this particular policy is flagging that most important of serious problems with any virtual machine in the cloud, which is it's running on x86-64 instead of ARM. You should be running ARM-64, of course, because it's much more resource friendly. That's a joke. Anyway, thank you. You made me feel better. So here we can do the same thing. Again, pardon my fumbling, but we are going to go back here. And now we're going to do the same thing. We're going to do a custodian run, but instead of basic policy.yaml, we are going to run filter policy. Filter.yaml. And it's going to come back, and you'll notice that the count has dropped from 2 to 1. And if we then run the report, and you can see running the report is real easy. You just, instead of saying custodian run, you say custodian report and give it a format. You'll see that the only resource that was reported was Debian1, which is a x86-64 instance. If we look at that other report, the original report, you'll see, the other one that it didn't report on is the one called Debian ARM64 GP2, which is, you can probably imagine, is the one that's the, that's the quote unquote problem child here, or, that we don't care. The one that's not a problem child, I should say, the one that is compliant with our policy of not using x86-64. So that's basically the most basic side of filters. And the idea is that you can pile more of these. This is a single, just a single condition filter. We're just focusing on one thing. You can do multiple filters. You can see this is an array. You can point out here in YAML, this indicates an array. And so if you had more than one of these, that's treated like an and. So you could say architecture x86-64 and this and that. Yes. Here, let me actually go ahead and yell it loud now, there we go.
I was just going to ask how the filters are defined. Are those predefined, or can you define your own, and how do you write them?
We'll get to that. Thank you for the foreshadowing. You're helping me out. This is the part where we have like the tension in the room. How will we find out? I'll tell you. In fact, I think that's actually one of the next slides. Let's see. Not a plant. Okay, nope. We're going to take a slight detour. So one of the things that you might notice is that there's this thing with key value pairs. So you got here architecture x86-64, and that sounds like it makes sense. Everyone should know what that means. The architecture is the key. That's the thing that you're looking for in the JSON, and you want to make sure the value is set, in this case, to x86-64. Makes perfect sense. However, if you've ever worked with YAML or JSON or any of these complex data structures, you know that it can go a little crazy. You can have objects inside objects. You can have arrays inside objects with arrays and more objects and then arrays, and on you can go. And it's like, does this mean that you can't, all you can do is just do those, the very top level? You can't get to anything else? And the answer is no, of course not. We wouldn't do it that way. The way that we solve this problem is with a specification, which you may not have heard of or you may not know about, but it's a very cool specification called JMESPath. JMESPath is a query language for JSON that allows you to extract and transform elements from JSON documents. The basic idea is that you can, like that whole path, if you've got like object dot with an array, with an object, you can actually create a string that will traverse that whole line. Here I have a few examples from the JMESPath.org website, which is a great place to go if you want to learn more about this. If you're sitting here asking yourself, hey, wait a minute, this is a problem I need to solve. Well, here you go. And yes, they have good Python support, so that's always a good thing. So here's a few examples of some of the things you can do with JSON that are kind of cool. And keep in mind that part where I said architecture, you can substitute stuff like this for that architecture line. You can do stuff that's all the craziness I'm about to show you. That can be the key in Cloud Custodian that you're doing the lookup on. So here, for example, you could see there's like a people, and you can actually do a query inside that. So there's a list of people, and you want all the people with an age that's greater than 20. And then when in that, you just want to pull out the name and the age items. So then you get a list of items, each of which is name, age, name, age, name, age, and the age in all these cases will be greater than 20. You can do fun stuff with what they call multi-select hashes, where you can say things, some of the same things. Let's see, we've got nested data, and here's where you can get into that whole object, array, / object, object, object. So you can see here, there's an array, an object called, there's an item called reservations, which is an array. So you want all of those things. Then you want all the instances inside each of those individual reservations. And then you want all of the tags where the key is the name, and then you want all the values. And that looks very intimidating. Maybe some of the Python folks are like, I can kind of get what that is, but the AWS people probably know exactly what this does. This gives you a list of all the tags, all the values, like not the keys, but the values for all the tags for all of these particular items. So there you go. They used an AWS example on JMESPath, which is kind of cool. So you can do all kinds of other stuff, filtering and selecting nested data. This is a particularly cool concept. There's that pipe symbol right before the 0 in brackets. And the idea is that you can do a bunch of this weird parsing. You can say, do this, do this, do this, and you're basically slicing and dicing everything. But then you might be like, okay, now use that to limit what I'm pulling in, but then I want you to reset and start over. And that's what the pipe will let you do. So it'll do the selection here for all of those things. It'll execute any queries, all that stuff. And then when you put in the pipe, it's like, okay, start over. And then you go again. So in this case, you've got people, and then you've got all this stuff, and then pipe to 0 means just grab the first one. That's all I want. So there's a lot more examples here. The path is up here, JMESPath.org. And like say, if you look at the top level, they have tutorials, examples, the specification itself, libraries, all kinds of good stuff. So that's something for you all to consider. And as I mentioned, wherever you see a key in a Cloud Custodian policy, that can be, you have the full power of JMESPath available to you, which makes things very, very interesting in terms of some of the stuff that we've done for one of the projects that I'm working on, which is doing some Cloud Custodian work. I've created some absolutely ridiculous looking JMESPath indexes, which I'm sure would be loads of fun for you to see. All right, so let's talk for a moment about filter types. And this is going to get to the answer to the question that was asked earlier. So if we go back and we look at that policy, right, this one here, you'll see that there's like a key value convention here. And you think, okay, that's real simple, right? This is actually a shortcut. This is not, strictly speaking, the way that Cloud Custodian is set up internally, but they create this shortcut because it's really handy. As you can imagine, key equals value, key value lookups are really common. And so they put this in as a shortcut. But the way it's really set up, and this gets translated inside Cloud Custodian, is a more verbose syntax that looks like this. Because every filter, it turns out there are multiple filters. Every filter has a type, and the most popular filter is the filter called value. And here you can see effectively the same thing. So what we saw 2 slides ago, this here, the architecture x86-64, this gets translated into this filter with a type of value, key of architecture. And again, you can do JMESPath here. value x86-64 operation equals. There are a lot of different operations that you can do. So the moment you break out of that shortcut syntax, you can do a bunch of fun stuff. Not equal to, greater than, less than, contains, in, not in. You can use regular expressions, which I'm sure all of you folks coming over from Perl are really happy about. You can use globs, which is kind of like file name globbing stuff. Yes, we have a question right here.
It's pretty simple in the sense of like you mentioned that filters are always and combined, I suppose. So if you have multiple filters, it's always and these.
Yes.
Is there any other more complicated Boolean logic?
Yes, you can do or and not as well. I don't have any examples in my here, but it is possible. Essentially, what you can do is if you see here where it says type value, imagine that there's an entry up above or colon, like right above it, and this is indented so that it's underneath the or. That's how that works. And so you can do that. And then, of course, within the or, you have multiple things, and you can do more ors or ands. You can kind of go nuts. You can add the nots, all those things that you want to do. All right. So this is just one example of the kinds of things that you can do with just the value filter. There are a few other interesting things. There's a thing called a value type, which essentially takes the value, and instead of just treating it like a string, like everyone would, and relying on implicit translations, you can actually say this value, do something different with it, not just the normal thing. So, for example, treat it like an age. So you can do time-based comparisons. This particular resource is 3 months old versus this resource is 2 hours old, that sort of thing. Size, okay, this thing is this big. There's a comparison that will take a string and, if possible, translate it into a CIDR, which you can then reference, like you can reference the individual pieces of the IPv4 address and the subnet and use those as part of your queries. And then swap, which is a really interesting one. I think I have an example. I may have an example of that later. Let me see. Yes, I do. So swap, and here you can see the age-based filtering type thing. You can say, okay, you've got a key of launch time, and that just gives you a time, right? So it's like, okay, I've got a time. This was launched at a certain point in time, and you want to but you don't care necessarily about the time. You just want it to be brand new. So less than 0.5, I think that's days. For the value type, and you just set value type equals age, and there you go. You've got it. It translates that absolute time into something you can do comparisons with. And here's the thing with the swap value type. But again, the AWS folks might know a little bit more what's going on here. You have essentially a key and then a value. But what happens is this gets evaluated, and you can see there's some JMESPath. It's not just a straight standard thing. That gets evaluated, and so it turns into an actual key here, so security groups 0, group ID, or whatever. But then you can swap it and use in to say, okay, this is a value that has this particular security group. So this is a way you can do searches on security groups, and you can actually do some searches based on the key. Like some of your stuff can be based on the key rather than having to be based on the value, where you have those flexible value key types when you're doing weird JMESPath stuff and you're not entirely sure what the key might be. You can actually search on it. All right. Now, there are all of this that we've talked about is all about value filters. There's also other fun filters, list item, and you can see this. So you've got a list, and for folks, again, the AWS folks kind of know what this is. For the Pythonistas, AWS security group, a security group is kind of like a set of firewall rules. And these are all applied as a group to some resource that talks on the internet, so that, for example, the hackers can't come in and just spam your whatever ports and try and find stuff and what have you. So in this particular case, we've got a security group, and we want to make sure that port 22, which is SSH, is not open to the entire world, because that would be bad in this particular case. But the thing about a security group is you have a security group and it has multiple rules. And so you don't just want to go through and, search for the rules, whatever. You want to make sure, okay, I want the rule. I want to know if there is one rule that has these conditions where the CIDR is this value here, which means basically the whole internet, and where the port is 22. So instead of like, that can be a complicated thing. You can do it in JMESPath. It gets kind of messy and nasty. So instead of having to force people to do that, they just do the list item thing where it says, okay, so here's your key, IP permissions, that contains a list. And now within that list, I want to do a further query just on the list items. This value, this is a CIDR that looks like that, and this is port 22. And so then you can do sort of like a subquery of sorts. And that becomes part of the filter, the list item filter. So if you did something later on, you could have maybe a different type of thing you want to look at for the security group, but you've already taken care of which specific, okay, this one does have a rule that's bad. So if you wanted to look at something else, you could move on to something else. This is another example of a filter, another type of filter. And keep in mind, it's all about this type list item instead of value. We're going to see a lot more of that. So here's a policy that does some other fun things. This one has, so here we have two filter types. We're getting a little ahead of ourselves. There's a type image age. You're like, what is that? What kind of filter would image age be? And we'll get to that in a minute. But we also have what's called a reduce filter, which is kind of, if those folks who like functional programming or have played with stuff, the reduce filter is a very nice and powerful thing. It allows you to, optionally, if you want, take a whole list of resources and you can split them into groups by some criteria. Then you can sort within the groups. Then you can pick, like limit them. So you can pick certain ones like either random or maybe the top 3 or something like that. And then you put them all back together. So you can do all kinds of funny transformations. I don't think I have it in here. Maybe we'll see it later. I don't remember if I put it in, but there was a filter someone called chaos programming, which was basically something that said, list all the EC2 instances, group them in this particular way, grab 3 random ones and kill them. Which was, that's one of those like chaos engineering. I forget what it was, the Netflix thing that they did. Yeah, Chaos Monkey. It was kind of an implementation of Chaos Monkey in Cloud Custodian. So that's another example of one. And then, as I mentioned before, there are custom filters. So most of the filters I've talked about so far, list item value reduce, those are generic. They work everywhere. This is a filter that is very specific to a particular resource. And again, to explain to the Python folks, when you have an EC2 instance, you need disk storage, some kind of storage of some kind. And in AWS, that is called EBS, Elastic Block Storage. And these are volumes that are attached to your virtual machine, and that provides the disk so that everything looks like you would expect for a virtual machine. There are a lot of different types of EBS volumes. At one time, well, there still is technically, but at one time there was a type called GP2, and GP2 was amazing and awesome, except that it wasn't. And Amazon decided that they were going to do GP3, and now it's like GP3 is the awesome thing. So of course, you know what you need to do. You need to upgrade. Well, how do you know which ones you need to upgrade? Well, there you go. Cloud Custodian to the rescue. And the idea behind this is your resource here, in this case, is EC2, and I forgot the AWS part, but this is AWS.EC2. So you're looking at the top level instance itself. You want a list of instances, not a list of volumes, because the volumes don't help. It's like you've got this list of volumes. You're like, okay, now I need to go find the instances that they're attached to, and how do I do that? Instead of doing that, we're going to do a list of instances, but then there's a filter. This is a special filter type of EBS that essentially sets up, it goes in and it's like, okay, I've got instances. Great, I've got this list of instances. Now I'm going to go in and do some more API calls and pull more data in, and I'm going to use that as the search. There's new search criteria. Here's another key and another value, and it's like volume type GP2. This is all coming from EBS. These are EBS things. You won't see it on your EC2 instance, but you will be able to search on it with that EBS filter. And the nice thing about these, and now here's where the Pythonistas get to celebrate, because I can actually say something that you're familiar with. The filters that are resource specific are written in Python. And what's even better is that you can create custom filters yourself. You can write Python. There is a plugin loading system in Cloud Custodian that lets you load a filter. And I think I did at least have on my other system. Let me see if I can pull this up. Again, sorry for the fumbling, but we are going to, hey, I got it right on the first try. I'm proud of myself. All right, so we're going to go to resources, and here we are actually looking at Python source code. Yes, this is all Python. You can see it. So let's go to EC2, right? And you can see there, if you were eagle-eyed, you can see right here, there's an ebs.py. So you can do queries on EBS on volumes, but sometimes you don't want to do that. So here we're going to do the look at EC2. And here I'm going to try and make this a little bigger so that people can read the code. And let's see, let's scroll down. Here you can see that we are registering resources. This is that plugin system. This is a talk in and of itself. We could do a long talk on how to write a plugin system in Python, but that's basically what they've done here. But if the interesting part is not there, keep going. There we go. I'll move it to the top so it's clear. This is the filter that implements EBS. And you can see, I just register it. I write a class that's derived from some things. So you build an API for your class. There's a little bit of documentation, which is always good. Everyone writes documentation for all your code, right? Everyone? Yes, excellent. All right. So, and then some code, there's some things that you call that it's like it's expecting to be able to call. And in the end, this is an actual callable. So it will just call this class at a certain point, Cloud Custodian will, when you define this. And that's all you need. Literally, that's all you need in order to register a filter like this that you can then refer to in your, there we go. Oh wait, no, I'm in the right place. Silly me. Yes, I need to be in the first tab. There we go. I'll get it right. So this type EBS, Cloud Custodian in theory might not know what the heck an EBS is in the context of an EC2 instance. But you might have written the code that registers that and makes that happen. And that's one of the really cool things about Cloud Custodian. You can expand its capabilities. If it doesn't do the thing, and this happens sometimes, the combinatorial explosion of ways in which various parts of your cloud service interact with each other, maybe they didn't think of the interaction that you now care about. Well, if that's the case, write your own and plug it in. And Cloud Custodian's like, yep, I can deal with that. Let's go. And you've got your whatever it is that you're looking for. All right. So this is all fine and good. We've talked about filters. You could do a lot of stuff. You can like, you know, build all kinds of things, you know, query things down, get all the information you need, create reports. It's all fine and good. It's all fun. Can you do anything more than that? And the answer is, of course, because I asked the question. What's the answer? Yes, of course it is. Why would I ask the question? You can take actions. And the idea here is that you can essentially say in your policy, as part of the policy definition, okay, here's the filters, here's the actions I want taken. Everything you find, every resource you find that fits the filters, I want you to do these actions to it. And this is an array just like anything else, so you can do multiple actions if you need to. So you can see a few examples here. In the action space for Cloud Custodian, there's really only one generic one, and it's called webhook. And that does what you kind of would expect. You can call a webhook, essentially, to make an HTTP call to the URL of your choice and throw a ton of data at it. And then you can do interesting things from there. There are a couple that are resource specific, and these are things that are AWS specific. So we can talk about some of these. You can tag, so you can add a tag to a resource. So like you've done a search and you want to keep track of those, maybe like keep track of them for later. You just say, I want to tag this. You give it the tag information, name and value. It'll attach that tag to the resource. Easy. There's something called mark for OP. So for a lot of things that you might want to do, you might want to do them immediately. And that's generally the way actions work. But maybe there's something that you don't want. Okay, I found a bad EC2 instance. I don't like this instance for whatever reason. It's x86-64. And who wants that? Right? So I'm going to tag, I want to mark this. I want to destroy this resource. But I don't want to destroy it just yet. I want to give someone the chance to repent of their sins and switch it over to ARM64. So I'm going to give them that chance and not destroy their workload just because I happen to see their transgression. And so I could say, mark this for an operation, mark this now, and then we'll give them, I don't know, a day, a week, something like that. We'll like come, see them at the water cooler and point our finger at them and start preaching at them and whatever else we need to do. And maybe they'll figure it out and they'll swap it out. Or maybe they won't because they're heretics, and you know how that is. So in that case, if they don't get religion in a week, kill off their resource. That's what we want to happen. But you don't have to rerun the policy. It does the marking for you so that later on you can say, yeah, that thing I said, go ahead and do it now. And then it'll do it. So I think I have an example here, a couple of examples. Here's an example of adding multiple tags. So you can see here's your filters. And here it's like, oh, we have EC2 instances that don't have environment or resource owner tags. They just don't have. And this absent is a special value, which doesn't actually mean absent. It is interpreted by Cloud Custodian to mean that tag, those two tags don't exist at all. So there are a couple special values like that, and I think there are ways to get around it. If you actually want a tag to say absent and be able to look for it, there's ways you can do that, but that's kind of a convention that they use. Then you can see there's an action, type tag, tags, and there's the two tags we want. Environment staging, resource owner in the AWS. So AWS folks, you have your resource now. All right. And here is a mark for OP. And here you can see how this kind of works. You start off with a EC2 mark to stop. And this is the actual marking part where you do a filter. And this is just a generic filter. It could be anything you want. And then your action is mark. You give it a tag name. You tell it the operation is going to be stop. And you want it to you want to delay for a day. So 1 day. Then later, you have another policy called stop marked, where it looks for those, and there's a filter type marked for OP. OP is stop, et cetera, and you can even specify your time zone to make sure that everything is kept the way you want it to be. And then for your actions, type stop, which means this is what I want to have. This is the action I want to have happen. So here you can essentially say on Tuesday, mark this for stopping. And then on Wednesday, it'll actually stop it unless you do something to stop it yourself or whatever it is you need to do. But at least it gives you that delay. So, yes. What stopped? How did this happen? I can't. And why does it say something about custodian status? I don't even know. For those who are online, there was a joke about this is a perfect way to prank your friends. All right. Now, I've talked for quite a while and probably should be wrapping up pretty soon. But before we do, I want to talk about a few fun, advanced topics that get into some of the more fun things you can do with Cloud Custodian. The first one is that for many cloud providers, including AWS, they have a notion of events. So all that we've done, all up to this point has been about running your Cloud Custodian policies. Like you've got a command line tool and you run the command line tool, right? And some of you have probably been thinking, oh, well, I could automate this. I could run this in, something like code deploy or something. You have a script that run, custodian run, blah, 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 does the thing, all that stuff. And you're thinking about how you would schedule that in AWS. You're going to CloudWatch, Event Bridge or something like that. And you've got all these thoughts in your head about all that stuff. And I'm here to give you the good news. You don't have to worry about any of that. Cloud Custodian will do it all for you. They will turn any policy that can be written in Cloud Custodian can be turned into a Lambda function that is then installed into your cloud environment and can be made to run the way Lambda functions are. How do you run a Lambda function? All of those methods can be used in something like this. And here I have a couple of examples. Like here's a periodic one, which is like once a day using this role. And for the non-AWS folks, a role is basically a set of permissions that, so your Lambda has permission to do certain things that are, because obviously you don't just want to, everything to have the ability to run anything. That's not good for security. And type periodic. And in this particular case, we're doing something to all S3 buckets, and we are running it basically once a day with the right permissions, and you don't have to actually run this. You don't have to, I forgot this morning, I forgot to do the Cloud Custodian. So you log in and you type, no, you don't have to do any of that. This will just happen. AWS will take care of it. Here's one for an event-driven system where it says type CloudTrail. This is a very interesting policy in that every time someone creates an EC2 instance, it will take this action and will mark it with a tag and value of foo equals bar. And it will do this for you automatically every single time that the instance is created. Now, there are some people, especially in the very strict compliance space, where the action here is terminate. You can imagine how much fun that is. So you create an instance and then immediately it dies and you're like, what the heck? And usually it's because you screwed up because there's a filter there. Now, if you think about this in terms of there's no filter here, yeah, that would be a really fun policy to have installed. Back to that pranking your friends. Yeah. What's that?
Is your filter x86 kill?
X86 kill would be the filter. Exactly. That's because anyway. All right. So that's an interesting, and like I say, this is an advance. There's like documentation for all this. Cloud Custodian's documentation is excellent. This is all described there. You can see how it all works and how to do it for yourself. Another fun thing is extended capabilities. You have multi-cloud. So Cloud Custodian supports more clouds than just AWS. They support Azure, they support Google Cloud, they support Kubernetes. So if you've got a Kubernetes cluster, you can do Custodian with it. They also support Tencent and Oracle, I believe. I think those are the other two. But anyway, generally speaking, though, it's kind of hard to do them all at once. Like you have to have your AWS policies over here and your Azure policies over here and so on and so forth, unless you use C7N org, which allows you to run multiple cloud providers in the same policy set. So you can have your AWS policies right next to your Azure policies, right next to your Google Cloud policies, and it'll all just work. The other one, and this is fun, especially for the DevOps folks, all you DevOps people, C7N left. This is shifting left. You've probably heard the term shifting left. Move it earlier in the cycle. The idea is that you can run your Cloud Custodian policies not against deployed resources, but against the code that would deploy those resources if you ran it. Specifically Terraform and OpenTofu descriptions of your resources. You can run Custodian on those policies before deploying them, and thus catch errors before someone creates a massive instance that costs you $5,000 per second or whatever it is. You can have the policy that checks for that and says, no, we're not doing that. So, all right. And a lot of these things, there's a lot of other extensions that these are just two that I picked out that seem particularly interesting to me. Again, the Cloud Custodian folks, I should pull that up just so that people can see it. I think it's cloudcustodian.io. There we go.
Yeah.
Documentation. This is the documentation. And like I said, there's all kinds of fun stuff in here. You can see here's all of your, it looks like I got the cloud, the cloud support right. There's your Oracle, your Tencent, your Kubernetes. There's the tools. There's a mailer. This is C7N left right there. There's special Kubernetes support. This is fun. Cask. It's the custodian command line tool, except that instead of running custodian on the command line in your local system, it runs it inside a Docker container for you. So that's fun. Log exporters, all kinds of fun stuff. So, and there's actually more that aren't here. So there's like a whole bunch of stuff that's really cool you can do. So there's the documentation. Obviously, there's a bunch of documentation on the specific, like here's the AWS reference, and you can see all the fun stuff that they support for AWS. Support for the other clouds tends to run a little bit behind AWS because AWS was the first thing that they built. But you can see there's just a ton of things you can do. And all of these are things you can query on and check on and make sure that they work and, do all the things. So. All right. And I believe with that, I am done. So now is the time for questions. Thank you very much for listening and being an excellent audience.
Awesome. There is a question online.
Go ahead online.
All right. So can custodian run from an organization's account to review all of our accounts and resources? For example, which one manages sub-accounts, different departments or cost centers in an organization?
I believe C7.org will do that, like not just multiple cloud providers, but multiple accounts. The other thing you can do very often that you might find yourself having to do is running the same set of policies multiple times against multiple accounts. Or if you're using the Lambda, the automated Lambda support, installing your policy Lambdas into multiple accounts.
Do you know how well it integrates with local stack?
With which, sorry?
Local stack
I'm not familiar with local stack.
for AWS.
Oh, I believe it. Well, that's a good question. Let's go see. We've got documentation here. We should use it. I don't see a reference to local stack off the top of my head, so it may not support that specific resource. But again, that might be a place where you could write a resource. Like you wrote filters, you can write resources and add that support. As I think that would work well for local stack as long as there was an AWS API to hook into. Then, you ask AWS and then it would do whatever it needs to do with the local stack stuff.
Stack just exposes a local version of the AWS API on your machine.
Oh, okay. So local stack is a local version of your AWS API. In that case, I believe you can configure custodian. It's probably through your AWS config setup, all that stuff. You can send it to a different API endpoint.
On Stack's website, they have a Cloud Custodian. Oh, wow.
Okay. The local stacks page has a section for Cloud Custodian. So apparently it works really well. So.
Yeah.
And if it doesn't work, Cameron will help you. He's the guy who knows everything. Right there. All right. Any other questions?
Formation.
Did you repeat the question for the online folks?
You mentioned Terraform and OpenTofu for C7N.
Mhm.
Does it support CloudFormation?
I do not know. I know that they reference OpenTofu and Terraform because obviously they're kind of the same thing. But I know that they reference OpenTofu and Terraform in their documentation. I don't know if they have support for CloudFormation or other like CDK or other frameworks for doing that. Pulumi comes to mind. I just don't know. Question back there. Calvin, cut me off if I'm going too far.
More questions, then we'll do the door prize right.
All right. So you mentioned that this integrates with Terraform / OpenTofu.
Mhm.
Are you familiar enough to kind of compare and contrast the roles they play? Because I know that you can do a lot of similar like querying stuff with Terraform as well?
Well, I think the best way to describe the difference between the two is that Terraform and OpenTofu are very much descriptions of what you want. So you say, I need 3 EC2 instances and I need a load balancer and I need, S3 bucket over here and all this stuff. And you describe what you want, and with an aim towards like Terraform or OpenTofu will then try to make that happen. So it's like, here's my description of the world. Does the world not match? Make it match. That's kind of Terraform and OpenTofu's strength. This is more like, hey, I just want to know if I've got problems. I'm going to describe things I'm concerned about. Here's this problem that I might have. Here's this problem I might have. And so they're very different spaces. You can imagine, for example, the number of problems that exist are going to be way more than you can specify in something like OpenTofu. I don't know if you've read any of the Terraform or OpenTofu providers, all the options. If you think of every single option you could present to every single cloud resource, and you want to make sure you specify every one of them, or you might miss one, that's not generally going to happen. So having something like Cloud Custodian on the back end that says, oh, when there is a problem, I'll go find it and I'll tell you about it. Maybe I can even fix it. Or alternatively, you can run it against your Terraform configuration and it'll tell you what you need to fix. Or worst case, it'll just send you a notice saying this is happening. And then oh, I got to go into my Terraform code and fix this. Anything else?
Go perfect.
Sorry, I had actually blanked about this, but I think what I was going to ask was, so you've got all these policies. Are there any open sets of policies? Because I can think about things like SOC 2 compliance or HIPAA or things like that, where there would probably be a lot of the same policies that would be needed across different companies. I don't know if those have been publicly collected in a location at all.
I don't believe, well, I'll put it this way. There are a lot of people who have worked on those types of things and they have their policy sets. I don't know of any public policy sets specifically, but I do know that there are some people who provide those types of services based on Cloud Custodian. So
You can mention Stacklet.
Stacklet being the main one. So that is, in fact, if I, to get into how they make their money, one of the things you can do is sign up for their premium service, which essentially includes policy packs for these sorts of things. And there are a lot of them. Any other questions?
Let's give
All right, I survived. Thank you.